So Kat, it dawned on me when I was looking at my video that number 5, you might not have actually been given that 50 degrees. I assumed you were, but I see that he drew it in blue. So how did he know that was 50? Well, the reason he knew that was 50 is because he knew that the angle D was a right angle. It's 90 degrees. Now, how did he know that was 90 degrees? He knew that was 90 degrees because it subtends an arc length that runs straight across the circle, which is 180 degrees. And we know that the inscribed angle D is half of its arc length that it subtends. And because it subtends, again, they showed you that it was the diameter by putting that point A there right at the center. So we know that's 90. And then we know that the circle has to add up to 180. So 90 plus 40 would be 130, and then you'd need another 50 to get to 180. And that's how he knew that this angle right here is 50 degrees, and then that, of course, subtends an angle, an arc length, I should say, that's double the 50 degrees, and that's where he got the 100 from. Hope that clears that up. So, Kat, this is like the problem that we did in the other video, only this time, it was the one where they'd given us, I think, 8 pi, and then it turned out that the circumference was 20 pi, and we set up a ratio. We're going to do the same thing, only this time, they didn't give us the arc length in terms of pi, which would be in terms of radians. Instead, what they did was they gave us the arc length in degrees. It's 120 degrees. And so he took that 120, and he put it over the circumference in degrees, which is 360. And then we can set that equal to, we know that the circumference of the entire circle A is 15 pi because they gave that to us. So we'll put the 15 pi on the bottom. And then we're trying to find BC. So I would put that on the top. That's the smaller one because BC goes with the 120. And now there's a couple ways you can do this. But basically you can cancel the zeros there. So you have 12 over 36, which actually reduces to 1/3. So you have 1/3 is equal to BC over 15 pi. And now we could just cross multiply there. So you'll get 15 pi times 1, which is just 15 pi, and then 3 times BC. And then you can just divide by 3 there. So we'll just get 5 pi as our answer. What he did was he reduced the fraction, the 120 over, he took the 120 over 360 and said that's equal to 1/3. So that tells me that if that ratio is 1/3, then the angles also have to be at a ratio, or the arc lengths, excuse me, also have to be at a ratio of 1/3. So he could just say, okay, what's 1/3 of 15 pi? And of course that just means dividing by 3, and you'll get your 5 pi that way. So either way, you'll get 5 pi as your answer. So Kat, this problem is just with respect to the relationship between a chord and the radius of a circle. And so the chord that we have is arc Q. And then they drew in the radius, and of course we know it's the radius because they told us O was the center of the circle. And if you have a chord that intersects with a radii drawn from the circle, from the center of the circle out to the circumference, it's going to bisect the chord exactly in half. And so that's how he knew that RS had to be equal to QS. And so he set those two things equal, or you could call it SQ, it doesn't matter which way you name it. But RS was x plus 13, and QS or SQ is 2x minus 1. And so he just set those equal, and he solved for x. And he gets x is equal to 14. But they actually asked you to find SQ. And of course, SQ is equal to 2x minus 1. So if we do 2 times 14 and then subtract 1, we get 27. So that's how he did that problem. So Kat, for this problem, he ended up just using the Pythagorean theorem, which I suspect you're familiar with. But how did he know he could use that? He knew he could use that because they told us that IJ was tangent to the circle H. And when you have a chord that's tangent to a circle, right at that point of tangency, the radius, if you come out and draw the radius, that would be HI, and then that chord that's tangent, you're going to have a right angle there. So we know that we have a right triangle. And then they gave us two of the sides. They said IJ was 8, and they said that JH was 10. So if we think of this as a right angle or right triangle, and then I could say that this side that I'm looking for is, say, B, and I could let 8 be my A, and 10 has to be C because 10's across from the right angle. So A squared plus B squared equals C squared. And so A squared, well, 8 squared is 64, plus B squared plus 100 squared, or excuse me, 10 squared would be 100. And so B squared, if I subtract 64 on both sides, is 36. And then if I take the square root on both sides, I get that B is 6. So that's how he knew that IH was 6. So this one, Kat, you're asked to write the equation of the circle. And remember, the equation of a circle is just x minus x1 plus, squared, plus y minus y1 squared equals r squared. So we just have to look at what we're given. We're given the center of the circle is at 3, -4. So we're going to say x minus 3 squared plus y, and then that'll actually end up being plus 4 squared, because y minus -4, of course, is y plus 4. And then r squared, if we square 6, because you were given the radius, is 36. And so that's how we got that answer. So, Kat, this one is maybe a little bit more interesting. I can see where you would have a little trouble following his work. So the first thing he did was he said that 4x minus 8 equals 100. How did he know that? Well, he knew that because we see that angle D is 80 degrees, right? And so the arc that angle subtends, that 80 degrees runs from K, I'm outlining it in pink for you, obviously, to U, okay? So this, remember, the arc that angle subtends is double what the angle is. So this is 160 right here, right? Now we know that there's 360 degrees in a circle. So if we take 360 and we subtract from it that 160, we're left with 200 degrees. And so now, and that's the rest of the circle, right? So if I go from K in the other direction and come around and meet U the other way, what I've outlined in green, that has to be 200, okay? So now what does that mean? That arc length is 200. You can see that angle C is the angle that subtends that arc. And so, because there's our points from C, and that is 4x minus 8. So that's why he took 4x minus 8, and he set it equal to 200. And then he gets 4x is equal to 208. And then he divides by 4 and gets that x is equal to 27. So that's how he knew what x was. And then to find y, what he can do is, you have a quadrilateral here, 4-sided figure inscribed inside a circle. So the 4 angles have to add to 360, okay? Well, we know that D is 80, and we just found out that C is 100, right? And so those two add to 180. And if we do 360 for the total minus 180, because remember, quadrilateral inscribed that has to add to 360, we get 180 again. So what I know now is that K plus U has to equal 180. So he took those two expressions. He took 2y plus 31 plus 3y minus 11, and he set that equal to 180. He didn't show all his steps there. 2y plus 3y is 5y, and 31 minus 11 is 20, right? So that's how we got the 5y plus 20, which is still equal to 180. And if he subtracts 20, he gets that 5y is equal to 160. And if he divides by 5 on both sides, he gets that y is equal to 32. The problem asks you to find the value of x plus y, so we can do that now. We can say that x plus y, so x, get a pen here, x plus y is going to be equal to, well, we know now that x is 27 and y is 32. And so if I add those together, I get 59, and that's where he got his answer. So Kat, this question combines a couple of things. First of all, notice that angle D, I'm going to go ahead and mark angle D. So right there, that's a right triangle. How do we know that? Because it subtends an arc length that's exactly 180 degrees, because we can draw across, like if we draw this, here's the angle it subtends, right? We know that's 180 degrees because it cuts right through the center of the circle. So that means that half of 180 is 90, and that means we have a right angle at D, which means we have a right triangle. And then there is a rule with a right triangle, and I think you can see in the picture, I'll outline it, that you have obviously a shorter and a taller side. If this is a right angle, the 30-degree angle they marked for you, this one down here, is 60 degrees. The smaller side is always across from the smaller angle, so that tells me that that side that they marked 6 across from the 30 is the smaller side. And there's a rule that says that when you have a 30, 60, 90 triangle, the hypotenuse is always twice the shorter leg. And so that's how he knew to double the 6 and get the 12. Now he has the diameter, and we know that the circumference of a circle is just the diameter times pi. And since we know the diameter is 12, the circumference is 12 pi, and that's an exact answer. So this one, Kat, is a little shorter. They want you to find the circumference if you know the area of the circle. So we know that area, the formula for area is that area is equal to pi times r squared, right? And they gave us the area. It's 25 pi. So 25 pi is equal to pi times r squared. Well, I can just cancel the pi's out on both sides, or you can think of it as dividing, if that helps. You're just dividing by pi on both sides. So the pi's cancel, and you just have that 25 is equal to r squared. So of course, if we take the square root there, we now know that the radius is 5. And then I can find my circumference, because circumference is 2 pi r. So 2 times 5 is 10, and that's how he got 10 pi for his answer. So this problem, Kat's pretty short. They gave you that these two chords, I'll outline them. They gave you that these two chords from O to T and from A to N, they marked those congruent. So that means that the arc length that connects those 2 points has to be equal, since the chords are equal. So in other words, the arc from O to T, which they gave you is 66, has to equal the arc from A to N. So that's also 66. Now that A to N arc is also the arc that the angle that they asked about. They asked about NFA, which I've outlined in pink. They've asked about this angle right here. Well, it subtends this arc length, which is 66. So all we have to do is cut that in half, and we get 33. So that's how he knew that the answer there was 33.